Good morning. Today I will be doing a short demo of Shop Floor Control for Sage 300 manufacturing. Right now I'm sharing with you the Sage 300 version 2014 edition. Here we have the Sage 300 manufacturing modules activated. That counts the manufacturing order module, manufacturing lot option, production planning, and Shop Floor Control. So under Shop Floor Control, we basically have the setup where we define the breakdown of the production floor. So we start off with the shift master. So here you can see we can define any number of shifts. We also have the operator master where we can define who or which teams of people are involved in recording tasks for shop floor. Notice how operators are assigned to shifts. We also have the station master where we break down the work center master which we have defined in the manufacturing order module. So back in the work center master, we defined how many machines or stations are available. Those stations are actually defined in the station master. And you can see how we link it back to the work center. We also have reason codes where we define reasons for downtime, indirect stoppage, and rework. Now, to avoid the user from having to select through a big selection of reasons, we basically link reason codes to work centers. So this way, a user using work center 1 would only need to go through 3 reasons instead of 100 or 50. We also have a user master where we can define default values for operator ID, operation number, work center, as well as station, and transaction type. Also note that we have here a shop transaction selection. So we basically have 2 ways of inputting shop times in Shop Floor Control. We call them the start-stop method and the time entry method. So for now, let's use the time entry method, which is the most commonly used one. So let's go to Shop Floor Control, Transactions. We are now opening the shop entry screen where you can see that we basically record the start and end date and time. So this time entry method basically requires the user to wait until the operation is completed before recording it into the system. So for example, if I did something from 2 o'clock to let's say 2:20, we could then select which type of transaction is involved. Is it a runtime, setup time, cleanup time, downtime, indirect stoppage, or rework? So for this example, let's use setup time. Which operator is involved, which MO, operation, work center, station do we use. Since this is a setup time, there is no need for output, there is no need for reason. Under the comment box, we can input any remark or comment relevant to this transaction and save. So this is now shop entry number 23, and it is recording the setup time for us. Let's create another example. So let's say from 14:21, which is 2:21, up to let's say 2:45, we were doing a runtime. Again, for operator 1, for MO number 3, you have here the operation, work center, and station. This time we have an output, let's say of 3, with a scrap of 1, and save. So this is now an example of a runtime entry using the time entry method. Now let me show you the second way of data entry. So let's go back to the user master, and this time let's select start stop. In this method of data entry, we basically require the user to just record the start, do the transaction, and come back and stop the time. So this is like a stopwatch approach. You can see that, for example, I started something at 5:15. So this is the start time. Let's say that we are doing a runtime for MO number 3, and then I'm now starting the transaction. Once completed, I go back to this record. So you have shop floor record number 25. I could then stop this time, and you can see it's automatically capturing the current time. I would then indicate the quantity produced and then save. So this is the other method of entry. Notice that this selection of entry mode is based on the user. So that means some users could choose to use time entry method, while others could use start-stop method. Aside from the shop entry screen, we also provide for a review entry window. So this is normally used by supervisors. So they could select date range and then work sensors involved. Here they have the option to review. If they find any record to be suspicious or looks incorrect, they could open it. So this is now going back to the original data entry. If they think it is wrong, they could just choose to reverse it or just do it from the outside as well. I could select this and reverse. So by reversing a shop entry, it is effectively canceling it, and then the user can then just re-enter the correct values. Aside from the transactions, we also provided for several reports and inquiries. So for today, let me just quickly show you the operation query. So this allows us to review the effectivity of the MO operation. So for example, for MO number 3, operation 100, we can see the current status, how much was already produced, how much was scrapped. We can see the setup time, runtime, and cleanup time being compared versus the standard times. We can see what is our effectivity, how bad or how good is it. And then here we can see the details of each record. If needed, we can open the detail window and it goes back to the original data entry. We can also do this from a station perspective. So if you wanted to see what has happened for station number 1 for this date range, the system can then show us the details. We can again open the original record if we wanted to. The system summarizes the utilization of this machine as well as in terms of in the downtime and indirect stoppage. You have here your percent utilization. Any time which is not used up would be just assumed to be idle. Aside from these features, we also have a cost allocation function. So if we wanted to use the time entries that we have created to allocate costs, that's possible. So all we have to do is select the date range, the resource type, and the system would then consider the total hours involved multiplied by the standard cost to arrive at a calculated cost. So if we, let's say, make this range bigger, so we have several MOs, you can see the total labor hours multiplied by the standard cost, arriving to an amount that we need to allocate. Clicking on Post would then copy these costs to the MO actual cost column. Just note, of course, that for the cost allocation function to be affecting MOs, it is required that we do day-end processes so that users input all the shop entries within the day or within the shift, have somebody process them together so as to add it to the cost of the MOs prior to MO closeout. So that's basically a basic demo of shop floor control. Note that shop floor control requires our manufacturing order foundation module to work. If you have any questions, please don't hesitate to contact us or your business partners. Thank you and have a nice day.